Hi guys, it's Simon C. Welcome to this new AI radar. A new deep learning algorithm developed by MIT researchers is designed to help machines navigate in the real imperfect world by building a healthy skepticism of the measurements and inputs they receive. For example, if the collision avoidance systems in a self-driving car blindly trusted adversarial inputs in the form of a glitch in the cameras that slightly shifts an image by a few pixels, the car might take unnecessary and potentially dangerous action. The team combined a reinforcement learning algorithm with a deep neural network, both used separately to train computers in playing video games like Go and chess, to build an approach they call CARL for Certified Adversarial Robustness for Deep Reinforcement Learning. In particular, CARL uses an existing deep reinforcement learning algorithm to train a deep Q network, or DQN, a neural network with multiple layers that ultimately associates an input with a Q value or level of reward. The approach takes an input such as an image with a single dot and considers an adversarial influence or a region around the dot where it actually might be. Instead, every possible position of the dot within this region is fed through a DQN to find an associated action that would result in the most optimal worst-case reward, based on a technique developed by recent MIT graduate student Wei Li Wang, PhD 2020. Researchers at the Department of Physics and Astronomy, University of California, and at the Brookhaven National Laboratory, Upton, New York, report the development of a training library and a deep learning method that can perform robust and precise item segmentation, localization denoising, and super-resolution processing of experimental images. Despite using simulated images as training datasets, the deep learning model can self-adapt to experimental STEM images and shows outstanding performance in item detection and localization. In challenging contrast conditions, and the precision constantly outperforms the state-of-the-art two-dimensional Gaussian fit method. Additionally, the researchers have deployed their deep learning models to a desktop app with a graphical user interface, and the app is free and open source. They will also build a TEMImageNet project website for easy browsing and downloading of the training data. It seems that IBM is seeking a buyer for its troubled Watson Health unit, and Fortune mentions an incendiary report by healthcare news site Stat News claiming that Watson Health's technology had never been validated and that the company struggled to live up to its own marketing hype. The report is based on accounts from 7 mostly anonymous former employees and also a trove of internal company documents and recordings of presentations. One big problem the former employees said is that IBM never clinically validated its capabilities. It was all made up, one former employee told Stat of the marketing claims IBM made for the health product. They were hell-bent on putting advertisements out of healthcare. But we didn't have the clinical proof or evidence to put anything out there that a clinician or oncologist would believe. It was a constant struggle. At the beginning of March, Alibaba and Tsinghua University jointly released the Chinese multimodal pre-training AI model M6, which was trained on more than 1.9 terabytes of images and more than 292 gigabytes of text. The system is pre-trained on a task that involves generating an image to match a textual description, and after training, it achieves state-of-the-art performance on a task known as visual question answering in Chinese, answering questions about a particular image. The system can also serve as a baseline for other tasks. The M6 model seems similar to the systems such as DALL-E and CLIP that OpenAI recently created, and somewhat similar to Facebook's Seer system. Facebook Jan LeCun says that self-supervised learning is one of the most promising ways to build machines that have the background knowledge or common sense to tackle tasks that are far beyond today's artificial intelligence. Facebook AI has now brought this self-supervised learning paradigm shift to computer vision. Indeed, they developed Seer for self-supervised, a new billion-parameter self-supervised computer vision model that can learn from any random group of images on the internet without the need for careful curation and labeling that goes into most computer vision training today. After pre-training on a billion random, unlabeled and uncurated public Instagram images, Seer outperformed the most advanced state-of-the-art self-supervised system, reaching 84.2% top 1 accuracy on ImageNet. Seer also outperformed state-of-the-art supervised model on downstream tasks including low-shot object detection, segmentation and image classification. The last component that made Seer possible was the development of an all-purpose library for self-supervised learning called Whistle, which they released in open source. In his newsletter The Batch, Andrew Ng writes that Alexander Z, Alexander Key, William Ellsworth, Oishi Banjarid and colleagues at Stanford systematically tested various models that were pre-trained on ImageNet and fine-tuned to read X-rays. They found that accuracy on ImageNet didn't correlate with performance on the fine-tuned tasks. ImageNet images differ from X-rays, and model architectures also influences results, so knowledge gained from ImageNet may not transfer to medical images. The team found no correlation between ImageNet accuracy and average expert or UC scores after fine-tuning. Specifically for pre-trained models, the spearmag correlation was 0.082. Without pre-training it was 0.059. However, ImageNet pre-training did lead to an average boost of 0.016 area under the curve in fine-tuned performance. Fujitsu develops facial detection AI to quantify concentration levels of people. Since facial expressions and behavior differ depending on the tasks involved and the cultural background in which each person grew up, this means that it has been difficult to develop AI models that could analyze different specific situations. With its new AI model, Fujitsu claimed that it can detect a person's concentration across various tasks due to it identifying common features and separating analysis by each muscle group, so it doesn't become easily influenced by the subject's cultural backgrounds. Okay guys, it's all for today. See you next time. Bye.